you very much. I'm glad to speak with you today. And when Anne approached me to give one of these seminar talks, I realized we were in the fourth 5-year interlocal agreement for the group on year 4 already. So we're almost to 20 years of getting ENWRA renewed. So it goes back to the beginning in 2006. As you're aware, natural resources districts in the state, there's 23 of them. The eastern 6 natural resources districts, or NRDs, are listed here. They're the main sponsors of our ENWRA organization. We also have partners agencies that deal with water in the state. So your Nebraska Department of Natural Resources, that handles surface water and also appropriations for basins, and all the NRDs are organized on watershed boundaries. So we're talking about the eastern 6 here. Your U.S. Geological Survey, the Water Science Center in Lincoln, they're another one of our technical partners. And of course, your Conservation Survey Division, or your CSD, that is here in 6th floor in this building at Hardin Hall at the school. So I am a CSD hydrogeologist. I was hired on in 2013. I took over for Dana Devine, who moved over to CSD here after she was the initial coordinator in the beginning. So I do owe a lot to Dana for getting the foundations all set up for the massive amount of data that we've been collecting since 2006. So with that, I'll just kind of talk about the regional setting specific to Eastern Nebraska first. Then I'll go into the partnerships of the agencies and the general structure of ENWRA since 2006 that's made it so successful. I'll dig into our early assessment history and then the application of our advanced assessment tool sets over time. So we'll kind of walk chronologically through one of those being the airborne electromagnetics, but we'll start with the basics first. And then a couple of our grant project highlights. We're closing up on a recent grant for recharge with the Water Sustainability Fund, your state funding for sustainability of groundwater. I'll go over several of those. And then our website, how do we get all this information out to the public? What kind of we get presentations like this, getting all that information out and available. And then upcoming work and Q&A at the end. Hopefully we'll have time. There's a lot to cover, so I might glaze over things really quickly, but it's a lot of detail. So starting with the whole state. So Nebraska, many of you familiar with the overall aquifer, what we call the High Plains aquifer. That's the light blue you see on the state map. Remember, we're talking Eastern Nebraska, something that pops out right away. You can see there's a difference there. So I'll kind of start surface and we'll work depth down through ground on the state here. The green hatch that you see, those are your stream valleys, your river valleys. They're shallow alluvial aquifers readily available to drill into and extract groundwater from. That's kind of your first groundwater. You can see how the High Plains aquifer, anything that's connected into that, so that's why it kind of comes into Eastern Nebraska along one of those the Platte River main area. You can see how between the Elkhorn and the Platte it kind of comes into Eastern Nebraska. So anything connected, they're calling the High Plains aquifer. But we have a lot of differences in Eastern Nebraska. So after this, we'll stop talking about Western Nebraska. But one thing is the glaciers. So we have, 1.1 million to tens of thousands of years ago. The glaciers came in from the north and northwest. They went, the oldest and farthest they went is down into northeast Kansas. So we have everything. They thought it was maybe 4 events. Now we're up to maybe 20 different advancements, retreats, melts. Came in like a bulldozer, that ice sheet left an irregular bedrock surface and then dumped a variety of fine grain to boulder size and no particular order below. So looking down from that alluvial aquifer system, we see the pink on here. So those are paleochannel aquifers. So imagine the green that we know of near surface streams and rivers bringing sand and gravels through. Now with the pink ones, they're older down cuts through into the bedrock of channels. And many times filled with sand and gravel aquifers that you can pump out of, you can even irrigate out of several of them. One we'll be talking about later, Todd Valley, and Dorchester, Sterling, Paleo Channel down here, or the Creek, Princeton, Adams, groundwater reservoir for that NRD. And now the brown, I'll draw your attention to, and we'll think subsurface in a few minutes, but we're just looking at a 2D map just so you know areas. Is the Dakota aquifer, or it's a Cretaceous secondary bedrock aquifer, and you can see it's pretty widespread in here, and that will dive down deeper underground to the west. One of the other Cretaceous aquifers, the ENWRA, which is actually a younger unit, kind of at the top. You can also get up to maybe 350 gallons a minute out of the fractured chalk that fills in with water for an aquifer material. We're not going deeper than the Cretaceous, so. Yeah, go ahead.
One of those, why there is a vertical line on that to Paleo Valley, there.
That right there. This is a big question mark, and we'll get to that later. I have another with the ENWRA, as far as the glacial limit is what we call it. And that's those bulldozers that came in, and I'll get into that. But yeah, this is the Blue River, something to pay attention to, totally different on the west side versus east side. Okay. So this is just a cross section from west to east. Everything we're going to be looking at, you got to think elevation on the left in feet above sea level, okay? From west to east across the north part of Nebraska. Remember that light blue, we were talking about the High Plains aquifer? On this, you can see it coming down in elevation towards the east, and you can see how it kind of pinches out here, and you're seeing that loess and glacial sediments on top now. The Cretaceous is this K, so that's that bedrock, that secondary, or that bedrock I was talking about. These are mainly shale units, except for that ENWRA I mentioned in the northeast corner. But the bottom of the Cretaceous is the Dakota, or we call it the Maha aquifer, when it's usable, good quality aquifer material, diving down to the west. But this blue patch is where it has good quality water, and for our secondary, but we're not talking anything below this. But back to 2D again, because we do talk a lot about the Dakota later. This is kind of the where you can find good quality water in that secondary bedrock. There are people up here with 600 feet deep irrigation wells in the Dakota. And then there are sparse irrigation wells in here trying to use the Dakota. And also we're in Lincoln. You guys might be familiar with the saline wetlands. One thing with the Dakota aquifer is you have that saline groundwater in the sandstone. So if you've ever been to Mahoney State Park off the interstate on the right-hand side, if you're going east, on the south side, there's some sandstone there. That's that Dakota sandstone. Okay, so back to in 2006, these Eastern Nebraska NRDs, Lewis and Clark, Lower Elkhorn, Pavio, Missouri River, Lower Platte North, Lower Platte South, and the Nemaha got together to form a coalition to assess the hydrogeology together. So it's a really complex, we've kind of touched on how complex it is, but this map is that glacial limit that I was mentioning, the red dashed line here, the glacial till deposits, so those are the dumps of clay matrix mainly, but anything from a fine grained clay to a silt to a sand to a boulder in the clay that can be up to 300 feet thick in some of these central areas. That's the coverage you see for our Eastern Nebraska area. And so pooling resources, we want to assess this together. We have similar setting types across all this whole area. I'm going to draw attention to Oakland, and for these red 3 boxes, because I'm going to talk a lot about those. Those were our initial study sites where we picked typical setting types that work in this area. And then I mentioned our interlocal already on 5-year increments. Those 6 NRDs, they pay dues annually into the ENWRA account to fund my position, and then also to bank money for our assessment work and grants that we go for. And so the organization We have it structured in a long-range plan and set out from the very beginning, and it's worked well. The technical committee is the water staff from each of the NRDs. Then they're the ones who go through the details of the scope information, and we run approvals through. And then, of course, the managers of those districts for final approvals. And then the technical advisors and agencies, DNR, Jesse Bradley has been with it since the very beginning, and all his staff. And Lincoln Water Science Center, we have several people, and of course our CSD. We have a long range plan that goes out to 2031, and we need to update that because a lot has been done, and I'll get to that at the end of this. But our main objectives have stayed the same over time. So identify the location and volume of all these aquifers we touched on. Estimate recharge.
Those recharge stations, are those for managed aquifer recharge?
Those recharge stations, and I have a page on them too, on the initial work, were just to try to get rates with heat dissipation probes.
Okay.
So I'll
So it's to measure recharge.
yes, that's how we started. We knew it was a big part of the equation, especially with the groundwater models and understanding that component. So it was one of the items we're trying to gather. And then assess groundwater surface water interactions. That helps with both the DNR and the NRD's purviews. Estimate the water budget, so total water in, total water out. We'd love to have the entire region in 3D where you can pull off the layers and see all the aquifers. That's our overall goal. Water quality concerns, sometimes we sample for things ahead of time that the NRDs might not necessarily routine sample for. Assemble, analyze, distribute data, that's big, which we'll go over, and always looking for the applicability of new technology. So I can't even go any further without acknowledging CSD and our state geological survey. In the first 2 years of our assessment, 2006 and 2007, there were about 40 holes that were done just for that Oakland, Ashland, and Firth pilot study areas. And this is just kind of an image. They've been doing a systematic approach to the state. They have test hole grid across the entire state, like 6,000 holes now in their database. Even in the 1960s, they started doing downhole geophysics in those test holes as well. So we have a tool that we send down our mud rotary holes that will read every 0.1 foot, the resistivity values and the changes, the electrical properties, and then also the gamma, which will show you the shale peaks. So just a background on that. With our early work, that was critical, the CSD work. Also, CSD has an archive of work that since 1872 that they've been keeping track of. And so in the early days of ENWRA, my predecessor Dana, and then Jesse Corris with digitizing all of the cross sections that had been hand drawn over the years. 1872 to 2007 is in a database you can get to on the ENWRA website by county, by township, section, range. And this has been invaluable, even today, still using it all the time. This was our first introduction to a hydrogeologic study. It's available on our website if you want more background similar to what I'm giving today. That was a really well done bulletin from CSD. Early assessment, again, monitoring wells. So not only did we figure out with the test holes all those different aquifers, we put monitoring wells at those 3 pilot study sites in the different aquifers. So the shallow alluvial, the potential glacial outwash, deeper secondary bedrock aquifers. We have 78 monitoring wells across those 3 sites, and we have about 56 of them with transducers in them that are recording water levels at every 8 hours. And by the Platte River, we have them going every hour. We also took samples quarterly in the very beginning from these monitoring wells for a variety of parameters. We did 2 aquifer tests, one in Hickman and one in Oakland, to get the actual characteristics of the aquifer. This is just an example of our water level data, elevation in feet on the left. This is the Ashland pilot study site that goes across the Platte River. So we have the Platte River floodplain wells down here. We have the Ashland Platte River gauge from USGS. It's on the north side of Highway 6 by Lenoa Beach. It's recording the gauge level for the river, so the floodplain wells up gradient to the north of the Ashland block kind of track well with the river over time. Then going up the hill to the uplands by Gretna, we've got a couple well clusters there with wells at different intervals. And then something interesting to point out, at the Gretna truck stop are two of these wells in the main primary aquifer area. But then there's a perched aquifer we also have, where there's sandier units up in that glacial material, glacial till, that is separated completely from the main aquifer unit. That does change over time, that is important in our area to consider. Also, the graph, this is just a nitrate graph from that Platte River floodplain wells and up into the uplands. So you can just get a rough idea. Instead, this is the cubic feet per second of that river gauge going past that Lanoa Beach area. And then also you can see how the concentrations potentially go with that. So these are all things that we started early and have been tracking over time. And then the recharge, which you asked about before, these are our stations. We have co-located with a weather station from the Mesonet. We have the heat dissipation probes at 1 foot, 2 foot, 4 foot, 8 foot, and sometimes deeper at the other locations. And they're just reading, censoring the temperature changes with depth. And then we just kind of stick them on a graph with ET and precipitation, so you can kind of just keep track of what's going on at those. And there was an early papers and work done by John Gates and others, where they went into detailed analysis. They had tracer data, everything, and kind of basically found out in the beginning we were missing 40% of the picture. Low-lying areas, sandy areas that were getting. This is just with the 2012 drought, if you're familiar, crop wilting. They did a paper with the results from the Oakland's recharge station. So now we'll get into the airborne electromagnetic surveyors, AEM. Okay, so these were our 3 pilot study sites. First time we flew the airborne technology, it was a project with USGS and CSD, working on the airborne, getting the public notified about it, because it was a strange looking thing with the torpedo hanging from a helicopter. Did tight space flight lines every 200 meters to cover those entire areas where we had the wells and the transducers and the detail. In the very beginning, we had interrelated water management program, IWMPP funding from the state. That the NRDs typically have, and use a lot of that money towards these pilot study sites in the beginning. That initial resolve, or we call it the frequency domain electromagnetics, basically would give you different slices of information with depth. And I'm really simplifying and not going to go into the geophysics because there's not time. But just think in your head, remember when we see bright colors, sand and gravels, coarser, high resistivity values, cool colors, blues, shales, clays, fine grained material, non-aquifer materials, if you could just kind of be thinking about that. So this is that one pilot study block. You could just see the river, sand and gravels, and kind of how they pop out for place. We also, for the first time, were able to make these 3D voxel models to get volumes of the aquifer materials, to get the aquicludes, or those fine grained materials that were separating the aquifers. And we got the whole 3D picture kind of starting to put together with these pilot study sites. Now, the block, which is down in that Dorchester Sterling Paleo Channel, one of those pink things we saw on the first map, that had an area, the gray that you're seeing here, with glacial till sediments and fine grained material that we were not able to resolve with this torpedo type equipment, the frequency domain, through those thick glacial tills that we have in the settings for eastern Nebraska. We did get upper and lower aquifer materials when it's resistive near the surface. And then the NRDs went through and got an NET grant and did 2 additional areas to build off of those initial pilot study sites in that reservoir down here in that Paleo Channel we talked about, and then another one south of Wahoo. It did not see very well on Wahoo to get to the bottom to really map the aquifers we needed for there. This is just an image of the spray put together with that first initial pilot study site, so you can get the information across. 2012, the Army Corps of Engineers, if you guys are familiar with that Meade munitions operation with the contaminant plumes of RDX and TCE or what have you, they did fly a flight block out there. Again, it didn't image down to the bottom of the sand and gravel aquifers that and where it meets the Dakota secondary bedrock. And it didn't do so well on tracking contaminant plumes like they had hoped, but it's still good information. So we got it through that natural resource district, Lower Platte North, that was in on all those meetings. So we do have that data. Also 2012, the drought. So we had a big drought. I came and started at the beginning of 2013, so coming off of that drought. And right at that time, the work that was done on the ground at those initial pilot study sites, they had ground time domain work done on the ground that were showing promise to get through that thick glacial till material. 2013, both the Lower Elkhorn NRD and the Lower Platte South NRD with their own funds decided that we need to get a handle on this because there's interference issues going on with the Paleo Channel aquifer here. We have 2 town areas. We're trying to find the volume of aquifer for that. And this is where we started using that time domain and seeing the benefit to see the full thicknesses. And one other great thing that came out at this time, and our experts that we started with at the USGS, some of them had moved to private companies, and luckily for us stayed through for all of our airborne and all of our geophysics data collection. So one thing that came out of it is Google Earth deliverables, so we could bridge that gap with the public. We did public meetings, sent out information that got it out as much as we could. I'm not going into the geophysics, but I will show you this just for the geophysics side of things. This is the frequency domain, electromagnetics. This is the time domain system. The hoop, I don't know if you guys are familiar, it's been going on and still going on every summer in eastern Nebraska. But there's a wire that makes a bunch of turns in a hoop. It's generating a primary electromagnetic field down into the surface, and then there's 2 receiver coils on the back end that are listening for that secondary magnetic wave to come back at different time gates and equating that with depth. There's a lot more to it than that. But the gist of it, you can cover a lot of ground and draw the picture between the borehole information very quickly. You can go 50 miles an hour. They're keeping that thing about 150 feet off the ground at all times. It has laser altimeter, knows where it is in 3D space, giving you what we call as a virtual borehole every 60 to 100 feet. And then it's picking up the electrical contrast in the layered earth materials, which, lucky for us, the aquifer materials show up resistant high on this scale of apparent resistivity, and the non-aquifer materials, your fine grained sediments, shales, clay, show up very low on this scale. So through this initial time domain work, we've kind of stuck with these categories of non-aquifer, marginal aquifer, aquifer, and coarse aquifer for the materials above bedrock. And for the secondary bedrock materials, we have a shale clay dominant or sandstone dominant. Now, sandstone should be showing up bright, high resistivity values, but when you add that saline groundwater into the pore spaces between those resistive grains, you're getting an overall very low resistivity, and we're seeing it like 10 and below on the scale. So you can see that pop out. That's okay. So all the 6 NRDs are involved. They all put money in. Everybody is working together as a group. We teamed with the DNR to fund these long reconnaissance lines. So we want to get each NRD covered about a county scale every 20 miles or so to see what this can show for their particular districts beyond those initial pilot study sites. And then the Lower Elkhorn NRD started their whole district process with the 3-mile grids at this time. This is the 506 system, so this is the largest system we've ever flown. It's the deepest sensing system. We haven't used it again after this. It's great because it had a dual moment, so you could get surface detail, even though that first surface layer was only 15 feet thick, and then it got bigger with depth. But it also had the deeper information down to like 1,500 feet in some cases that we were able to see. And again, with the KMZ deliverable, remember I said the dots every 60 to 100 feet, they want the information so that you could see where these lines were that they flew, and then you could also see what's the elevation of the ground, the 1995 water table elevation, the top of the bedrock, those primary coarse materials, where's the top and bottom that we think on that, and the different contacts with the bedrock. So this was at 1582 down to 208, so like 1,400 feet for this dot example by Pierce, Nebraska. And here's just another view from south to north. This is one of these long transects up here in Cedar County. And you can see the counties and how they are in the town there. But the big thing on this one is you're just seeing this regional picture. You're seeing that secondary bedrock aquifer where it's more resistive in the Dakota on the north side here. You're seeing this Carlisle shale, the Cretaceous shales that we mentioned earlier. It pops out very, very low resistivity value consistently across our whole region. The Pierce shale is another shale that shows up really low resistivity that you can draw in very well. That Niobrara, the orange we saw on that first map where the chalk is fractured, that's a little trickier. And they did have some mistakes in the beginning interpretation of that, but we're learning more and more and more now that we do the inquiries with the data. And then the overall, we talked about the high plains kind of coming into eastern Nebraska, that light blue color on that 2D map. The best they could do is this orange line here for that, and it's still a lot of work needs to be done with what is considered the Ogallala versus those younger sediments. And they start putting the CSD test holes and summarizing them in a certain way. You can see the glacial till is this blue at the test holes that matches up with the blue at the top of the glacial sediments that you see on this line. Okay, so yeah, we're putting this whole picture of all these borehole information, the downhole geophysical logs. They actually use some of the geophysical logs to calibrate and constrain the work for using to interpret the AEM data. So that was really lucky for us that we had that. And then also the DNR borehole summaries. I'll get more into that later on a later project, a description, but that's critical too to filling out the information with the AEM. And then the monitoring well networks, the NRDs are constantly designing. This is helping inform that. And we've done a lot of test holes. So test holes, this is that downhole geophysics, the blue, green, and black lines that are detailed that we see downhole. And then the red is the AEM model, we call it. So basically at that sounding that was flown over this borehole. And we have the downhole information. This is what the AEM results are going to be showing. Non-aquifer, marginal, and aquifer. So it generally matches, but there's a lot of lumping going on here. So I just want to point that out. And our historical cross-section work, sand yellow, just remember that, silts brown, Cretaceous green. This is an actual cross-section with the test hole. This is what the AEM looks like under that line. What you'll notice, I'll point, you might not see that little sand and gravel at the bottom that could be critical for that local area. They might not see it on the AEM. And this is what the interpretation looks like. And all we have for all of these reports at this time is the 95 water table, the dashed blue line that you'll see on these. So by the time you're 500 feet down, it's lumping information every 50 feet. And it gets bigger with them, so. But one fascinating example of what the features that you can see with this data, especially in the regional sense, from west to east, there's a flight line from 2016 that goes almost to Bennington from south of Columbus. And you can see what the interpretation is along that line, how that bedrock dips down to the west, outwash sands, and end rain, so we're one of those advancements of the glaciers stopped and dumped a bunch of materials. And you can even see these thrust deposits there. The Todd Valley, one of those pink paleo channels that we saw coming through here. Platte River Valley, how that might all be connected with the water table, just kind of putting all those items together. So where we're at today, as of 2024, these are all the flight lines and it's different color for each event where they went and flew. Everything that was the frequency domain and that initial up to 2015 to time domain is in blue. And then each of the colors after that is the SkyTime data since then that has been flown. And these are the coverage of the new test holes that have been done in our area since we formed it. So what do we do with all this data? CFD has the Nebraska GeoCloud, ENWRA is the funneling agency through 10 natural resources districts across the state that fund, ENWRA ones are part of that too. To get all that data, common format, same place, accessible to consultants, accessible to the public. So go to this website of Jesse Corris's, he's the lead on the GeoCloud to get more details with that. But this is the interface that you can upload and you can download and you can draw cross sections and look at the data. And one big thing, this is a crazy slide, but the GeoCloud for that project up to 2019, they summarized all the boreholes, registered wells included, and committed them to these categories and color coded them so that they sort of match up with the AEM resistivity values and optimized it for the contrast that we're seeing with the sand and gravel and the other non-aquifer units. So this is Jesse's one of examples on a profile where he's got a bunch of different things laid out here. So this is what a deep borehole with 880 feet by Tarnow, Nebraska looks like summarized next to the AEM data. So when I help people with public inquiries, I just kind of summarize it to this short list or whatever usually. And then we do have a 3D program. This is a program from IGIS out of Denmark. Denmark is who kind of in the very beginning we went with because they have their whole country pretty much covered in EM surveys. And we want to learn from them and also team with them as part of the GeoCloud project because we get the benefit of any advancements that maybe other countries involved in the GeoCloud get and vice versa. But this is a free viewer you can download so you can look at any of the projects that are built, and we have them built for each of the 6 NRDs. Highlighting our recent grant project. This is the most recent one through the Water Sustainability Fund with the USGS and CSD. This left-hand slide is the near surface, so the top 10 feet basically, and it's broken. Conductivity and resistivity are inverse of each other. So this is just showing the very shallow. So remember gravel red, sand and gravel, blue is the glacial till thicknesses. But look at how much more you see when you dig down 50 feet. So this one on the right with our project goes down 50 feet. So they were able to take all of that airborne data up to 2023 data, which was good because it was at the very end of the project and they still were able to run it. And then CSD created a interactive project map for this. Here's the QR code if you're interested that has that top 50 feet of AEM image from USGS on there. And then it also talks about the focus areas. So we knew we want to cover the whole region. There was going to be details involved with the focus areas across NRD boundaries that we wanted to get the current water levels, the current bedrock, depth of bedrock, the current saturated thicknesses, and then also create cross sections. And this is just a profile view for you to think about that top 50 feet. A to A prime would be this red line of all the different things that could be going on in that top 50 feet. And the pure shale we talked about before being a non-aquifer, so even though this looks good, there's no water in it. The main aquifer is down here. And these are the cross-section examples that are derived. We're still gonna do cross-sections to show you the story of what's going on, but the difference is now we're using the AEM data along with the test hole data to create the cross-section understandings. And so this is that Dorchester Sterling Paleo channel we talked about. This is in Saunders County, Dodge County, I'm sorry, across the Platte, north to south. And then on the website, every report we've done with all the AEM, the recharge, the pilot study, well data, the archive that I talked about, all of that's available on the website with this new resource browser. We just got it in July of 2024 and upgraded our old website that had been the same format since 2006. So we're pretty excited about this. And the best is this map button you can hit at the top right, which will take you to an interactive map of flight lines that you can click on, and then it'll take you directly to those report lines for each line, the subsurface profile interpretation. Another thing I want to mention is we did do a reconnaissance of the secondary bedrock aquifers age dating work. And that report is available, but we definitely want to do more with this in coming years to supplement with all the data we've collected. And then the NRDs themselves are working with the Department of Natural Resources. Laura Elkhorn's got their own model area going to fit into the groundwater numerical model of the lower Platte Missouri River TRIBS model up here, and then the Nemaha watershed model down here. These three NRDs are working together in a current grant to get their geologic models all kind of stitched together. Again, that's the interactive map I was mentioning. I want to put another plug in for CSD's map because they have our flight lines plus the test holes, registered wells, the hydrographs for the groundwater monitoring wells that they do. So, in review, we've done about 20,000 line miles of AEM for eastern Nebraska. Over 200 test holes have been added to ground truth that information and supplement all of our work. The partners, you know, they're using the NRDs to manage groundwater quantity and quality. They need a scientific basis for their decision making and quantity and quality. So that's what we're providing through the ENWRA work. They permit wells, they use the AEM data to evaluate with that. And also it works back into enhancing their monitoring networks for what they need to be specifically looking locally. And of course, CSD and USGS, they're incorporating it into the publications work. So we're just constantly building those basic scientific data sets available for eastern Nebraska. I know public inquiries, they only increase with time, especially with the drillers now are really getting into it and asking questions. Hey, what does the flight line say in this area? I got to drill a well for somebody. Is it better over here or over there? And of course, our GeoCloud, we want to keep that going because any updated model surfaces, we're going to keep cast in that same platform. So going forward, we still have more work to do. There's still a lot of questions out there. We've gotten all done. We still have gaps where we need to fill in. We've got lots of different advanced technologies we still want to look at, like nuclear magnetic resonance. So if you have down a borehole, you want to get the water content of the aquifer units outside that, additional things like that. Continue working with DNR and the other partners on that numerical model interfacing, and our cooperative efforts together is kind of how we got the success of getting a lot done today. That was a lot. Yes.
The new transects that you've put together, where are those housed?
The new, these things?
Those guys, yep, where do you keep?
Okay, so right now for that, grant. He's the master of these online interactive maps. Created this, and you can get this QR code, or you can go to the ENWRA website on the about page, and if you touch the map, it'll go to that website. Yes.
So are there any other states that we like share an aquifer with that do like research like this that is similar?
That's a good question, and I meant to mention, you know, Nebraska is kind of one of the world leaders of applying this airborne technology for groundwater mapping, off of what we learned from Denmark. And we have Kansas, Minnesota, other states looking to us as an example. Hey, how'd you guys start going about this, and what should we plan for or expect and build it for our states?
Katie, you did a great job, as always. Could we go back to your Portchester, Sterling, et cetera, Paleo Valley section?
This
I
one,
hadn't seen
this
this.
is a bias angled one that goes across right in here.
So are you? What is the fault, or what appears to be a fault in the cross section?
This thing right here, you
Yeah.
mean? Oh, that's a geologic contact.
Okay, so it is, so it's
That's the
it's
Dakota
exaggerated. I think it's.
exaggerated.
Tell these people that
Yes,
these are so highly vertically exaggerated that
yes.
point to the diagonal line.
So that Dakota is dipping down to the west.
Yeah, but point to the line so they can see it.
This
That
is the
isn't fault,
contact.
that's the contact. that
Yes. This
Looks
is
like
over.
a high angle feature, but in fact it's not. I was just curious there because I've seen the others, but I hadn't seen this one.
Yeah, so that's 100 million years old.
And of course, I'm assuming it's exaggerated, but I
Yeah.
couldn't even begin to read the vertical scale today.
From 100 feet over a mile, so it's not much.
I was wondering if there's like a way you decide where to put a test hole and like how deep to go.
Yes, so with the NRD, but if the NRDs had a priority area of management where they had a lot of questions, we would go in those areas and do those different intervals, figuring out for them. But as far as the state geological survey, you know, that's their mission to answer all those questions separately on their own program. But for us, it was driven by the NRD management areas, if there was well interferences, those type of things. But we did learn that we were even benefiting from doing test holes under the flight lines after they had been flown. So we did them in the pilot work in the beginning, but then it was also really beneficial to give you that characteristic detail of those aquifer units hands-on. I can look at the sample and know and get that geophysical downhole information.
You want to describe anything about the history of test hole drilling and how it was done in the past, how sites were selected?
Yes, I in the beginning, we were talking about the history assessment of since the 1930s, and we're kind of doing the mud rotaries things the same as we did in the beginning because it was tried and true, uniform way scientifically to describe the cuttings.
But in those days, for a long time, they were trying to drill on basically a grid, a
Yes.
rough grid pattern. Every what? 6 miles, something like
Yeah,
that.
you have 6,000 of those now in the database, yeah.
So I know you mentioned both NET dollars and also NRD dollars going towards this, which implies some sort of public benefit. So
Yes.
what are the benefits for generic public who are reaching out to your office or those you disseminate these results to? Well, like, what's the positive impact for the folks?
It
going
could
here?
be irrigators that are having trouble with a well or need to put a new well in. And they don't know what direction on their land would be maybe better or worse. So they come in and say, hey, what do you got for this? Or the drillers are now coming to get that detail rather than just, "Oh, my pipe will only go this far, I'm gonna put it in this corner," kind of a thing. Also for, you know, towns, they have those wellhead protection areas that they have to worry about, the vulnerability of those aquifers. They are even was it Creighton or Coleridge up there in northeast Nebraska used the AEM data to kind of say, oh wow, there's a boundary here. This has got aquifer material, this not so much, and it helped inform those time to travel maps. Yeah, those are just two examples.
The recharge stations, what are those gonna be used for?
So those were the early days that we just keep collecting the data. We lost the one in the Todd Valley to mice, chewed up the entire thing, and there's also badger holes, so I don't know about putting another one back in there. We're building off this recharge grant that we just finished up is to gather more sites for measurements. So where we see that high, moderate, and low, the red, green, and blue that we saw on here, oops, yeah, oh, sorry. On here. That'll help inform where we need to get these rates figured out more. We have some rates early on. They did this method we did with the USGS, John Nemo, where he took stream gauges and precipitation and transducer and tried to get these snapshots,
It's just, it's a different way to try to estimate recharge
yes.
across the whole region.
Regionally speaking, yes, so there was the profile scale.
It was a calibration station.
Yeah, and out of that, for 2014 work, 56 millimeters per year is kind of what they came up for the whole region, but there was a 0.002 at one station versus like a 400 down in the river valley, so it pointed to that big error, yeah.
Okay.
The good point you said, John Nemo and Jim Constance at Menlo Park, they did a lot of work on the heat as a
Yes,
tracer for a recharge. Yeah.
yes. So we kind of gave them our data sets from that early information and asked for, what do you recommend? And then we did some of these recession model things. But if there's a well pumping nearby, it kind of messes up.
But I had to go back to that.
I want to know how the data is being calibrated, that AEM data is being calibrated, the board data.
So those download geophysical logs in that 2014, 2015 timeframe, there was about 56 of those that they actually used in the processing of that AEM data to help constrain those units at the very beginning. So it's a process where it's looking up and down the line in AEM to the nearest points, up, down, left, right, all three directions, and then also using some of that information in the beginning.
I noticed that there are some area where there is no flight line for.
Yes.
Are,
Areas.
are those like urban areas?
So it's expensive, I didn't mention it, but the 2018 flights that we did that covered the whole, was like $3.2 million project or whatever. The gaps, it was more like bang for your buck on covering the priority areas. And if you had a lot of wells already, we thought, hey, we've got a lot of data points in here, so we might not need to fly it, but it kind of turned against us a little bit in some of these areas because even people not using them, that secondary bedrock aquifer is still important, and especially how water transmits through it. And then over here, to speak over here, we have shallow limestone and shale units and no groundwater availability. So the money wasn't worth it to cover these areas that didn't have a significant used aquifer. And also power lines. So on a small scale, all the dots that you saw where we had those virtual boreholes, the gaps was if there's a power line, that signal will just couple to it and you won't get any data. So that has to all be chopped out. So that's another pro for having this all covered as soon as we could is more development that goes on, structure, infrastructure, can't fly it.
And you said a little bit about the Blue River and the geology, maybe if you can elaborate.
The trickiest one. So the flights that they, I'll see if I can get back here without making everybody dizzy. So the flights that they just did in 2024 in the summer past by Beatrice, they're even seeing on a couple lines in here where they have the saline groundwater coming up to near the surface. So it's messing with what the AEM is seeing below. This is an edge. And it's really complicated, and actually Lower Big Blue should have been probably in ENWRA in the beginning, just because they're part of this glacial limit area. They just weren't one of the partners in the beginning, but now they're looking to potentially join ENWRA and get the benefits of having a coordinator with all the AEM. And they're planning 2020 to fill in this area here. We have a state map in Pickerel and Claytonia. We're planning down in this area too with CSD. So, you know, they could join maybe the ENWRA group. But I haven't personally dug into this area that much beyond looking at their initial pipelines.
Nebraska is kind of lucky when I look at the Oglala High Plains. Aquifer stops right at the boundary line with Kansas. For some reason.
I got one that's really not the technical side so much as the not political, but the social side of this. How did ENWRA come to be as a association, basically? NRDs primarily, and instead of being housed in a specific agency or organization.
Right, so I'm actually stationed at the Lower Platte South NRD, but I am with your state geological survey. In the very beginnings, I believe it was Lower Platte North was the main housing entity of the ENWRA group. And that was 2006, before my time, as far as that initial politics of how the whole thing started. I don't know, Matt, if you know more about that 2006 timeframe, but
It's all a blur.
It's what?
It's all a blur.
It's a blur.
they had been working with Jesse Corns,
Yeah.
Sulak, and, you know, with all the geological issues.
Women's coverage is something that could be housed in conservation survey.
Yeah, I would say,
And them landing a coordinator from
Yeah,
the
but-
beginning too.
But I'm curious on this the way it is.
we share with the NRD, who's done an outstanding job with coordinating this project.
Uh-huh.
But to really do it all justice, we'd have to have a few more people dedicated to this. Don't you agree?
Yeah, I wish I could split.
So you know, the drivers for doing it this way versus another way, that's what I was thinking.
Right. And it's worked out with the interlocal agreement that we just keep on 5-year cycles, and then we keep that coordinator sub-agreement with UNL on that same 5-year increment. And we keep trying to go for grant money and keep everything.
All right, well, thank you very much.
Thank you.